Okay, so I hope that you enjoyed your break. And now let's talk about this name and main. The way I try to explain to people is that I usually ask them what they are called. And so now, because we are in Zoom and I can't really do that, my name is Gabor, right? So people call me Gabor, but when I talk about myself, I rarely talk about myself as Gabor. I usually use I, myself, me, right? So I have this self-referencing something. And this is the same with all of you. So all of you have your own personal name, and from the outside, people use that name, but from the inside, you all call yourself I, myself, me, or whatever is the same thing in your own language, okay? So we all reference to ourselves with the same exact name, but from the outside, we all call something else. And this is sort of the same idea with this strange looking variable. So this variable has two underscores and then the word name and then two underscores again. And this is a variable that Python sets its value. And if I now print this out, let's print this out, the content of this variable, okay, we'll see interesting things. So I run Python appy, and it says that the content of this variable name is actually two underscores on both sides and the word main. And what if I run the Python use app? Then it prints out that it is in the main variable, in the name variable, sorry, it is the value app. Okay. So this is sort of the name of how the program calls itself. Okay. Yeah, it doesn't talk too much, but think how the program thinks about itself. Okay. So when I run the program directly, it says I am the main, just like we all do, right? For ourselves, we are the main. Okay. So this is called, the program calls itself main. But when I use it from another module, so when I import it and I ask what is that thing called, then that thing that thing introduces itself as up. Okay, so just as I would, when I talk about myself, I call myself, or I think myself about myself I, but when I introduce to someone else, I introduce myself to someone else, I don't say it's me, or it's I am, or I say it's Gabor, right? So that's my name. So this is sort of the same idea. So in this variable underscore underscore name underscore underscore, there is the value of how the thing thinks about itself, the program. And it either calls itself main, or it calls itself its own file name. Okay, so remember this we are in the app.py file. So this if statement checks whether is the name of this program underscore underscore main. If it is, then call this function. And in this case, we are calling the main function. Okay, we could do anything here. Okay, so right, yeah.
So it's a good practice to always call the main function in this way. So we will not have this problem of like.
Right. I think that the real ideal thing would be that you would have a separate program and a separate file for library. And then you don't need this whole thing. Okay.
Yeah.
Okay. That would be the ideal. But apparently many people use this construct that they sort of have a single file, and in the file they have functions and also the main function, and then they have a separate test, let's say. And for that to work properly, it's a good practice to use this.
Okay.
Okay.
Thank you.
So in general, I think it doesn't hurt. Okay, this if name if and we call this called underscore because it's double underscore. That's sort of the Python Pythonista. Wow, that's another word that Python programmers use, that they are Pythonistas. And this is called the underscore. There are many of these underscore constructs in Python. They are all sort of internal to Python, but sometimes they are used by developers. Less so. This one is probably the main one. Well, okay, it's called main. The most common one, commonly used at the beginning when you start programming, and then later on you will encounter other ones, and you will start using the other ones as well. The main thing that you have to remember, if when you see these double underscores, so two underscores on both sides, that is something internal to Python. That's probably the, and then you have to get, and you can search for it, but at least you understand that it's sort of, it's not real magic, okay? It's just, sorry, I have something in my throat. So the fact that we called here main, it's just really minor thing. Maybe this whole thing could have been implemented this way. I can leave it that way. Okay. So let me comment out this whole main function. So we don't need a main function. This could have been done the same way, right? This would be same. Python app before and after, and Python use app, and it's just prints out the app now. Okay, so that would be also fine. They're both. Okay, it's also, but in general, it's also a good practice to have a function called main, because it clarifies things a bit. So now back to this code. What was the name of the file? I forgot. Manipulating CSV. So you can see that this is the problem. So we should probably put this whole thing into this construct, and which probably should say if name equal to main, then do this, and of course, and then it would be fine. Let's actually even show PyTest. Okay, so now the tests pass. Okay, and we can run the Python. Forgot the name. Manipulating CSV. Python manipulating, and that works too. Okay, of course I would. Again here, wouldn't include the name of the file, because this means that you can use this program now only on this file name. I would use, let's say, sysargv to get the name of the file from the user, and that's how I would continue running the program, and that will make it a lot more useful. Okay, another one here, Maher. Or Maher, I don't know how to, again, sorry if I mispronounce your names. Git status, so there's one thing. Okay, the PyCache, you can see the PyCache. It's untracked, okay, so it wasn't included in the GitHub, but you can see it because there is no gitignore file. I tried to say it, but if I put gitignore, I create a gitignore in the root, so in the root of the repository, right here. No, I don't go into the day6 folder, and I use, sorry, vim gitignore. I use this editor, and I put here the name PyCache, and run git status again. St is just status for short, and on my computer, status. Okay, then we don't see that PyCache folder anymore. We still now the gitignore that we need to commit, add and commit to the repository. But that means that from now on, we won't see the PyCache, and so we won't by mistake add it to Git. I remove this gitignore for now because that's not our thing here. I won't go and start changing the repositories of people. So what did I want to show you here? Review the code, unit test, name. Okay. Oh, actually, I think we covered most of these things already. So it's fine that the. Okay, so right. Okay. One of the things I wanted to show you is the use of unit test. So there is a generic name called unit test, which is used in the programming world. And the idea of unit testing, okay, one step back. We want to test our program, okay? We want to verify that the program works as we planned. Fine. And this is called testing in general. And then there are different levels of testing. You can test a single function, or you can test the whole application, or you can test part of the application, and so on. And for whatever reason, the programmers gave special names for these types of tests. The most lower, let's say, tests, when we are testing single functions, they are called unit tests. And then we have integration tests, which are when you're integrating several parts of a system, and acceptance tests, where you want to verify the whole system together. It doesn't really matter, but that is in one place where we use the word unit test. Now in Python, they created a library called unit test, but these two things have really nothing to do with each other, okay? So the first one I explained is what the level you are testing, okay? The a single function or the whole application or whatever, that's one thing. And the other thing is the tool that you're testing with. And I think it's rather unfortunate that they called this tool unit test, because this causes some confusion, but that's it, that's what we have. So there is a library, and it comes built in with Python, which is called unit test, and you can write tests just like the way we did with PyTest, except that you need to write all these extra things here, like this one, and the setup, and you have this assert almost equal, and no, that's actually not part of it. So it has a different way of writing tests. I think that in general consensus in the Python community is that we are moving away from this library, the unit test library, and moving towards more and more to the PyTest library, because it's way more powerful, and you don't have to write all kind of things that is the unit test library you need. But it's fine, okay? At the end, it's fine if you're using the unit test library. So I just wanted to show you, first of all, but I guess for the unit test, you need to do this one. This, again, is not probably not a requirement to have this one here in order to run the unit test, because I can use the PyTest to run even tests that are using unit tests. So that's totally fine. So I can use the PyTest library, even if the developer used the unit test library to write the code. Here you can see the use of the name main. That's one place. Again, here we have the hard-coded files, which is not a good idea. Okay, again, because this way, this is the main program. So the only way to use this is to create that input file, and it will overwrite this output file every time. And if you run it with one input and then you forget to save the output somewhere, then the next one will just overwrite it. So you be careful with this. it's usually better to get from the user the input, the name of the input file, the name of the output file, and then maybe you can check whether the output file already exists and don't overwrite it by default, okay? Because you don't want the user, who might be yourself, making a mistake of overwriting a file without any questions. So maybe you want to ask the user to do that, and so on. There was a yeah, okay. That's so far, I think. Now back to Roy, I think, but it also can. Okay, actually, we can go back to Roy because I think I saw it there. Day 6, git status. Right, okay, let me remove this file and then I'll show you what happens. So we don't have this file. I run pytest, and the test does all kind of things. It generates some bar plot. And now if I run git status, the file appeared, okay? So this is sort of a problem, because now I can mistakenly add this image to the repository. It's sort of also a problem because if I run the test again, and let's say the test crashes, but what did the test check? So let's say that, no, not the test crashes, the program itself actually doesn't work. But the assertion is checking whether the image exists. And if I ran the test once and it worked and generated the image, and now I run it again, and it doesn't generate the image, but the image is already there, and the test will pass. Okay, so that's probably not a good way to test. You either want to remove the image immediately after the test. Okay, one idea, or I usually do, or you might want to make sure before you run the tests. So before you run the generate bar plot, check if the file is there and remove it if it's there. So before you, and then afterward, check if it's there. So these are the things. You can also use what we call a temporary folder. And I think some people use some temporary folders. So you can, it's sort of the ideal way probably, is that for the test, there is a library called temp file. And you use that temp file, which will create a temporary folder or temp folder. You create a temporary folder, you create the image there, you check if the image is there, and then you probably even you don't even need to deal anymore with the temporary folder, because the next time you run the test, it will generate a new temporary folder. And at one point, the old one will be removed anyway. So you don't have to care about, and that's a useful way of, especially during testing, to create these things. Alternatively, you probably want to, if you really want to keep generating the image locally, then you probably want to put the name in gitignore file, so you won't add by mistake to the Git repository, because then it sort of breaks the test idea. Okay, I don't remember this one. I put there something, but I don't. Shahar, day 6, test. Starts no, sorry, editing the Excel calcs fun. Yes, sorry. Right. So here, I think too, there was the problem. I'm not really sure anymore. of how do I test something that generates a file and asks, oh, okay, right, no, I think I remember. The main, let's see the main. Okay, so first of all, I mentioned to you that we can use TK to ask questions. So this is what happens here. It's called tkinter. Let's try to run this program. Python xlcalcs.py, and it opened. You see this window, and then I can browse the folders. I can go one folder up somehow. It's not perfect, okay, and I can look in the 5, let's say, folder. So I can let me try to enlarge it. I don't know if I can. Maybe the letters are the same size. Can I? No, I can't enlarge, so you can see it better. But it's sort of like this Windows window that lets you find a file. It has the advantages, and for me, it's mostly disadvantage, but you can use this if it can be convenient for some people. So this is one thing that you can see in this project. The problem that, sorry, Shachar encountered was that now, okay, in order to run the program, you have to ask the user all kinds of questions, the name of the file, and probably a couple of other questions. And then how can you test this whole thing? So my recommendation is that to separate the whole thing of getting input from the user, that's one step, and then calling a function with the already accepted input parameters, the name of the file, whatever values, and then that thing generates maybe a file or something, and then now you can test this one without dealing with the input, getting the input. Now, what if this code generates an Excel file? You could, and this is what I do in some of my projects, run the program once, it generates the Excel file or whatever, the image, okay, as we saw it earlier. I look at it myself, manually, so to say, verify that the data is correct, and then take the whole file and save it in a separate folder. So let me show you in one of my projects how it's done. Work banner builder, site examples. Right, yes. I think I actually showed you this early. So here I have the input of the program is a YAML file and the output is an image. So what I have is I created for the tests a YAML file, generated the image. I looked at the image and said, okay, fine, this is what I want, and saved the image here. And it's in the GitHub, okay? I added this image to GitHub in this site examples folder. And then the test goes over all the YAML files, generates the image in a temporary folder, okay? And then compares that image with the one that I already saved here. And they should remain the same. So if I add a new feature to the YAML file that now it accepts, I don't know, colors, let's say, all the YAML files should generate the exact same image. Just now I can create a new YAML file with color, let's say, okay? So the test should, with all the old data, old input, it should still generate the old output. So now the test can compare all these things. And once in a while, I decide that I might change the whole system and say, okay, now it needs to generate a new image. Let's say why? Because I had a default font, and let's say I changed the default font. So now the default generated images will be different. First of all, if I have users, they will probably not like it. But as this project specifically doesn't have any users except of myself, so it's fine for me. But then I changed this basic thing. Let's say in your case, you change, Roy was creating an image. Maybe Roy decided to change the colors of the graphs, of the, what was that? Bar chart. Fine, the image will be different. But now Roy can, or in this case, I can generate all the new images, look at them, say, oh, they are fine, they look good, and then save the new images, replacing the old expected image, because now I manually check that I changed the code, I know that the images should change, maybe just the font, maybe some color, maybe whatever, and then I can save these new versions, and that's it. Okay? That's a good way of testing something. At the end, this whole testing thing provides you security. So just as you go with just regular insurance, life insurance or car insurance, or I don't know, whatever insurance, you travel insurance, why do you pay for that? Because you say, okay, I put in a little money in order to make sure that if there is a big trouble, I won't have to pay a lot of money. Basically, this is the idea of these insurances. Okay, and let's put aside whether the insurance companies actually pay us or not. That's a separate story. So these tests are sort of the same idea. You invest a little bit or some in creating the tests in order to make sure that you don't break something by mistake by chance later on. Okay, so which will cause, or which can cause, a lot of damage. So this is the whole idea. And then how much you invest in this, that's up to you. It's up to the risks you have in the project. It's up to the costs you will have if you break something, right? And I think I mentioned you, if you're writing an application like, I don't know, Facebook or whatever, where people click on likes, and if you miss one of these likes, what is the cost of that? And on the other hand, if you are building a starship, okay, and you're flying whatever it's called, a rocket, okay, or an airplane, what if something goes wrong there? Obviously, the cost is the cost is way higher in that case. So you will probably invest a lot more in testing. Okay, and so that's the thing. But once you know how to do this, I mean, I personally invest quite a lot in testing, almost all the time, because I see how much time I waste if I don't have the test, and then I break the code, and also because I already have a lot of experience with testing, so it's easier, right? I guess at the beginning it's going to be it's more difficult. Okay, any questions? I think I covered now everything that I wanted to cover with the assignments. So next thing, I would like to talk a little bit about the project. We are already on session 7 out of 10 sessions. So it's time you start working on your project proposal. Actually, with this last assignment, we made a lot of progress and towards a project. So let me explain what the project is about. So after, you might remember, the grade is 10 assignments. One of them is the timestamping, and then a final project. And the final project has basically 2 parts. First, you write a proposal that I have to accept, and then and that's 15 points. And then the project itself is 35 points of the final grade. But without this project, you you won't pass, okay? Even if otherwise you have like 60 points. So you have to do this. Same with the proposal. The proposal is, so you will have a project, and in the project you will have a README file describing what this project does. We already had something like this now with the README file. So this is just going to be bigger, like let's say 3-4 times bigger than what an assignment was. Okay, if you want to know what is the size of the expected size of a project, let's say it's like 3-4 times bigger than this assignment we had. And you need to write a README file that describes what the project does. And basically, that's the project proposal. Okay. So in order to create to propose a project, you will create a repository for the project, a new repository. So it's not going, because now it's yeah. Okay. So that, because it's going to be a real project. Okay. So you create a separate repository, you put a README file in there, and you open an issue, just as we did earlier, with the link to this repository when you would like to submit your first, when you would like to submit your proposal. And once I accepted it, you implement the project in that repository, and then we can continue on that one, on that issue, and you do this project. That's the technical part, the technicality of the project. What should be in the project? The idea behind the project is that you do something that is really, really useful for you already. Okay, hopefully it's part of your studies, right? Okay, so we already actually in the last assignment did something, because I asked you to pick up an Excel file or some CSV file and do some analysis. So take this idea. You can even take the one that you already started to do now and enlarge it. Okay, so you don't have to come up with some totally new idea. You might take the one that you started now and make it bigger, make it more interesting. Okay, that could be a project. Or you can do something totally different that can be useful. Okay, so the idea is that you create something useful that nothing to do with the directly with. So it's not something that I come up with and give you some assignment that's nothing to not related really to your work. Okay, I would like that this project. I mean, my hope is that you do this project now, which might be even just a partial implementation of something much bigger that you need in the lab. And then you hopefully will continue this project later on. And I don't know, whatever comes out of it. Okay, so you don't, it's also an important point with this project that you might come up with an idea, but you say, oh, but it's way more work than what you think should be invested in this course. I say to you, cut it into smaller pieces, okay? Think about the smallest piece that is reasonable for this course. So again, 3-4 times bigger, let's say, than the last assignment, and do that part of the project. So don't do something that's not relevant or not interesting just because it's small. Okay, do even a part of a larger project, because my hope is that you will continue it, and I would like you to come out from this course with something that not only with the knowledge, but also with something, a program already you implemented. Now, of course, some people don't have, some people are not connected to labs, or maybe they don't have anything in the lab. Fine. In those rare cases, you can do something unrelated to your lab work or to your studies. Some people did all kinds of interesting things. You can look up the projects from the previous course. You can see all of them, some of the older projects. Now I hope that we will have more and more of these available as we start to do this through GitHub, because in earlier courses that were all privately shared, and so we can't you can't really see the projects. Some people build games, some people build, I don't know, tracking an application to track their expenses, whatever you like. Okay, if you have any questions about the project, then feel free to ask me either now if you would like to, or those people who are here, they have this advantage that they can ask me live, or in the email that you're sending, or just write a proposal and I will respond to it. I will have to set the date for the proposal. I will put it in the README file along with our assignment. Okay, I'll just have to think about it. But basically, I would like you. I definitely would like you to that all of you will finish the proposal part, and I will accept all the proposals by the last meeting, last lesson, which is. Now is the 7th, 8th, 9th, so 3 weeks from now. That's fine. Probably I'll set the deadline a little bit earlier. And then you will have time to implement the project. The sooner you do, the better, in my opinion. Okay, but people like to do things last minute on the deadline. Okay, let me move all these things to the README now. And go to the next point, which is getting data from website and then scientific Python. Let's see if I can.
Sorry, can I ask a question?
Yeah, sure. Go ahead.
About the proposal, is there a specific format you would like?
No, not really. So make it as a README file. Make it nice as you can. If you would like to include links, okay. If you are referring to something, okay, I'm using whatever, and then you give some name that's very obvious to every biology student, but for me it's not. So include a link there. It's a README file in the Markdown format, right? README MD. So if you would like to include an image, then put it in the repository or whatever. You can embed an image, just as we learned on the website, right?
Okay.
Okay, so but it's basically beyond this, it's free format. Just think about it that eventually this will become the documentation and the README of the project. And you would like to reach a point where someone random on the internet can look at this project, at the README file, understand what it does, and say, oh, this is exactly what I needed, and I start using it. Okay? Someone who's studying similar things. Okay? One thing that in the last course, there were 2 or 3 people who said that they have whatever they are doing is not published yet, so they can't put it in a public repository. I'm not very happy about this, but because it would be nicer if we can show everything. But in the rare cases, if this is the case, that's also fine. Then what you will have to do is create a repository which is private. Okay, when you create a repository on GitHub, let me show you. When I create here a new repository, I can say that it's private. So it's only you who can see it. And then there is some place, I forgot now where, I can look for it now, where GitHub workshop, not subgov. I think here I'm looking for it now, settings, and then collaborators, and you have to sign in here with extra security, and then you can invite me as a collaborator, so I will be able to see this repository, and then I can look at it, okay? And I could actually change it, but I won't, of course, okay? So, but ideally it would be, so let me just get there, subgob with, it was still called bootcamp back then. So this is the repository of the previous project, and you can see there is 1, 2, 3 people who had private repositories, but that's it. And back then I allowed people to work together, but now at this time I think everyone should. So you can work together, but each of you have to have your own project, okay? So I actually recommend people working together, but then you still have to do 2 projects, or you just sharing, helping each other, okay? And then I will put so once you open the link to the project, I will put the link here. And if it's private, I will mention it, and then people won't be able to access it because it's private. But maybe later, once you publish the material, maybe you will be able to make the repository also public, and then it will be even better. Okay, so you're also welcome to look at all these things that they did. That will give you ideas of what you could do. Okay, and you definitely have to do better, because I hope that the course improved, so you have to also do better than they did, like nicer README file and so on. Any more questions about the project? Okay, so I'll actually start with the scientific Python part now, not the other one. And I'm going through a little bit the slides, partially because I personally use way less these things, but it's I give you an overview of what we have. So there are lots of libraries in Python, probably tens of thousands of libraries that are more relevant to science than to other things. And here I just gave a list, and some people in the course already used some of these. So there is the SciPy library, the BioPython library, which all kind of features, the NumPy, Pandas, which is also, it can be used for many things, but scientific projects use more. There are 1, 2, 3 libraries for drawing, scikit-learn, that's for machine learning. We don't go into basically, we will take a look a little bit about the BioPython now. Scikit-learn is machine learning, TensorFlow is more machine learning, deep learning actually, others, okay? Airflow and Luigi are pipelines, data pipelines, and tons of them, okay? This is not really interesting. I wanted to go over a little bit about the BioPython part. And here too, the first thing you have to know, and probably some of you already know, that so one of the things you deal a lot with, or many of you deal, are sequences, okay? And the sequences can be, they are using 4 letters, right? But then you want to store them somewhere. So you can store a sequence just as a series of letters in a file. That's fine. But you also would like to store all kinds of metadata about these sequences. And there are several of these formats. There is the FASTA format. I think I linked here to the Wikipedia page. So the FASTA format looks like this. I guess this is the name of the the organism, right? And then this is the whatever sequence with all kind of strange letters. Okay, I have no idea what it is. Okay, but the sequence is stored some way in metadata. So there's the FASTA format, there is the FASTQ format, the EMBL format, the GenBank format, tons of formats with more or less data. And these are just plain text files, nothing very interesting. But the question, how can you read it? And just as I mentioned that you have the library to read YAML files and JSON files and whatever TOML files. Remember, I think last week or 2 weeks ago, we discussed these. Just as you have these libraries for the generic but standard format of YAML and JSON and so on, the same way there are libraries to read the FASTQ, the FASTA format, read and write, FASTA format, FASTQ, GenBank format, and so on. And the libraries are all in this BioPython huge project. And so this is what we can do. Let me try to write this. So but actually I'm going to copy paste some of them from here. So I'm trying to deal with sequences. I'm creating a new file, and the first thing I'm going to copy. So this is from the BioPython library. So I put it here, and I'm going to save it into the day 7 folder. Sequences, Py. And here I cd into the day 7 folder, and I run Python sequences. And it complains about the no module name bio. And I don't remember now, and we'll add it to this one. I think I need to install. So it complains about the module Python. What I need to do is pip install BioPython. Let's try with just bio, I think. Okay, I hope that it is installing the right thing. Yeah, it tells it installed the BioPython. You see? Okay, now it ran. It just doesn't do anything. Okay, so let me just put it in comment that we installed pip install bio, and this worked. Okay, you can also say, I think, pip install BioPython. And then you can do things like this. Okay, so that's before actually the format. So it has this sequence class, like you see. I put it there. So it's a class, and I can give it a sequence, and it will provide us a representation of this sequence. And this is what things like we can do. Of course, I can. So it's not just the string. It also knows about the fact that it's a sequence, and it has all kind of methods. Okay, so let me copy these ones. So the printing my DNA would just print out the same sequence, and but I can use then complement or reverse complement or transcribe. So there are all kind of methods that are relevant to a sequence. My DNA dot, and then you can see all the list of all the things that you can do. Okay, with this. Some of them are like generic string related things. Some are other. So I run this one, and you can see this is what it printed here. I just have the comment showing what it should print. Okay, and then you can also use this. If you provide an RNA, you can do this. And here, this one is getting some data that's incorrect because it's neither this, neither that. Okay, fine. And I think we're going to have a break now. Okay, because it's 55 now. Okay. let me just check something else. Yeah, that's a good time to have a break, because then we are going to start talking about the FASTA and GenBank files. So this one, what we saw now first, is just a generic thing that can handle sequences. If you have in the pocket some sequence or what, you can deal with it. And then the next, so 10 minutes from now, 5:11, we are going to continue with this sequence. Okay, so see you then.